All right, so perpendicular lines is what we're going to talk about here today. Let me see here. Do I have? Yes. Okay. If you remember from Friday, we did a warm-up, right? And our warm-up looked like this, where we had you plot 2 points, draw that line, and then find the slope of that line. So there is line AB. We found that slope to be -3/7. And then I also had you plot 2 other points, C and D, and then draw the line between those 2 points, and then find its slope, the slope of both lines. We saw that both lines are the same exact slope, -3/7, right, which meant that these 2 lines are parallel. And in fact, if you look at the picture, right, they look like they're parallel. They look like they're not going to intersect. So we said, right, that in coordinate geometry, 2 lines are parallel if their slopes are equal, right? It makes sense. They should intersect. But then I had you do something else here for number 3, right? I said plot point A and point B. There's those 2. Okay, and then draw line AB like before, and compute that slope. So you did, you got 3/4. Okay, you can either count it by rise over run, or you could use slope formula. All right, but then I had you plot point C, 5/1, and I had you draw line AC. So still using that point A, draw line AC. Okay, and I asked you to find the slope of those 2, of that line. Sorry, the slope between those 2 points, or the slope of that line. And we ended with this number, -4/3. All right, and we saw that these 2 lines, they intersect. Right, but they intersect in a special kind of way. What kind of angle are they creating when these 2 lines intersect? A right angle, 90-degree angle. That's right, okay? That means these 2 lines are perpendicular, all right? So there's also a relationship in their slopes. Because these 2 lines are perpendicular, their slopes are, well, they're opposite and reciprocals, right? This slope was positive. This slope was negative. This slope was 3/4. This one was 4/3, okay? So in order for 2 slopes to be perpendicular, they need to be opposite of each other. One should be positive, one should be negative, and they need to be reciprocals. That means they should be flipped, okay? And that's the idea here. So that's what we're going to be talking about today. All right, so just like we can write the equation of parallel lines using the same slope, we're going to be writing the equation of perpendicular lines using the opposite reciprocal slopes. So the key to remember here is that perpendicular lines, okay, have slopes, okay, that are opposite reciprocals. Okay, if you don't like that word reciprocals, you can just think flip or flipped. Okay, they are flipped. Okay, so we'll start off with a problem kind of like we did for the warm-up here. We'll just start off with an example. So we'll ask the question is, and guys, you can cut the conversation, all right, is EF parallel or perpendicular to GH? Okay, is line EF perpendicular to line GH? So this little symbol here means perpendicular. Okay, that means perpendicular. Okay, that's the symbol for perpendicular. You can see it's basically 2 lines, right? You got a line here intersecting, well, kind of like a little segment, I guess, really. A segment kind of intersecting another segment at a right angle. It's like an upside down capital T. Okay? So, E, we'll say, has coordinates 1, -4, and F, we'll say, has coordinates 4, 2. G, we'll say, has coordinates -1, 2, and H has coordinates 5, -1. Okay? And so we want to find the slopes, right? We want to find the slopes of those to determine whether they are parallel or whether they, well, are not. Okay? So, to do that, we're going to use the slope formula. Okay, one thing you could do is get a piece of graph paper out, plot all these points draw the two lines, and then like count the slope. That's absolutely a strategy you could use here. So you could plot the points, you know, graph the lines, and then come up with the slope by just counting it. All right. We also have the slope formula though, so let's go ahead and do that since it's already kind of set up for that. So slope of line EF. Okay, let's find that one first. Alright, so let's see here. I'm going to call on someone. Oh, someone who's here. So Debbie, how we set the slope here for line EF? Okay, so 2 minus, careful, negative 4, right? 2 minus negative 4, because it's the subtract the y coordinates, and then subtract the x coordinates. So you said 4 minus 1? Yep, good. All right, so there's our setup. Again, we subtract the y coordinates on top, we subtract the x coordinates on the bottom. If you forget that, if you feel like you always get that confused, remember slope is rise over run. Rise over run. And the rise, that deals with the y coordinates, right? The y coordinates go up and down. The run is the x coordinates. They go left and right, okay? So rise, y coordinates over run, x coordinates. All right, so 2 minus negative 4, we can change that to, with same change, you can make 2 plus 4, so it becomes 6. 4 minus 1 is 3. And Debbie, does that simplify anymore? Yeah, what does it become? 2? 2 over 1. Yep. 2 over 1. Good. All right, let's try another one. Let's do the slope of the next line here. Let's do the slope of line GH. All right, let's see here. Oh, someone who's here. All right, so column W. What's the slope of this?
Negative 1 minus 2.
Okay, negative 1 minus 2, good. Over?
5 minus 1.
5 minus negative 1, right? Yeah. Good. Okay. So, negative 1 minus 2 is negative 3. 5 minus negative 1 plus positive, right? Because again, minus and negative, same thing as plus positive. So 5 plus 1 is 6. And so that simplifies to, what would that simplify to there, Colin? Can you simplify that?
1 over 2.
Yeah, negative 1 over 2. Okay. Good. Thank you, Colin. Let's see here. So, Tristan, are these two lines perpendicular? Looking at those two slopes there, are the two lines perpendicular? Yes? Yeah, that's right, they are. Exactly right. The two lines are perpendicular because their slopes are opposite reciprocals. Okay. Slopes are opposite reciprocals. All right, I'm going to have you guys try one. So you all try here just to make sure. So we'll go back to AB and CD. Is line AB perpendicular to line CD? Okay, that'll be the question. And I'll say A has coordinates 0, 3. B has coordinates 3, 1. C has coordinates negative 4, negative 3. And D has coordinates 0, 3. All right? Let's go ahead and check that. I'll come around and help as necessary, but just go ahead and determine that on your own there. Are those two lines perpendicular? All right. Freeze it. Boop. Okay. Just gonna make sure you calculate those slopes accurately. Does anyone else, by the way, need a calculator rental form? Does anyone need a calculator rental form? Okay. I know some of you guys took that calculator rental form. If you took a calculator rental form and you still need a calculator, make sure you get that back to me, right? The test is coming up on Tuesday. It'd be really helpful to have that paper. Really helpful to have that paper. Find those slopes. Find those slopes. So are they perpendicular then? You don't know, okay? So look at your numbers. You have negative 2 over 3, you have positive 3 over 2. So are they opposite reciprocals? Okay, well, they're the opposite reciprocal. So opposite means one should be negative, one should be positive, and the reciprocal means they're flipped. Right, you can simplify that slope, the slope number there, the fraction. Okay, good. Good job. Very good. All right. Josh, you gonna slope your calculator? All right, well, let's just start. So scratch your phone. Be careful. Positive 1, take away 3 is not negative 4. Okay, because right now, if you look at these two slope numbers, they are not perpendicular, right? One's negative, one's positive, but they're not reciprocals of each other. That's 4 over 3, that's 3 over 2. So, but 1 minus 3, that was negative 1, it's not negative 4. Yes. Yes, that's good. Well, I think good job, Josh. So, you found that slope, now you find the slope of the other one. Like you found the slope of D to this line, AB, to the line CD. Yeah, so again, remember, the slopes have to be the opposite reciprocal. So opposite means that one is positive, one is negative, and the reciprocal means that one is 2 over 3, the other one is 3 over 2. You understand? So it has both the opposite sign and flipped. Okay.
Come on, yeah, I get it there, but.
Okay, good. Don't forget you can simplify 6 over 4 so you can actually compare it to them. They both divide by 2. Yeah, okay, so. Oh, yes, okay, yes, be careful with that. Okay, good. Okay, don't forget to simplify that 6/4 because then you can compare them. Okay, see a lot of good things here, folks. We're going to keep moving. All right, we're going to keep moving. So the so let's go ahead here and do this real quick. All right, I have a volunteer that wants to give me the volunteer. Alex, go for it.
Okay,
What's the slope of line AB, or how'd you calculate it? What's your setup first, please?
So I tell you how I did it, or just tell you? Okay, I just.
Hold on a second, Alex. All right, listen up, folks. All right, go ahead. What was your formula used here? What was your setup?
I put 3 minus 1.
Okay, 3 minus 1 over?
Over 0 minus 3.
Over 0 minus 3. Great. Okay, and what does that become then?
I got 2 or 3.
2 over, and 0 minus 3 is negative 3, right?
Yeah.
Okay, good. All right. Question?
Where you get this 1 from?
So, find the slope of AB. Okay. 3, 1. Oh, you did? Okay. No, that's 3 and a 1. That's a 0 and that's a 3 there. Okay. So, all right. Melissa, how about the slope of line CD? Okay. So that's one way to set it up. Yep. 3 minus negative 3 over. Very good. Okay. And so when we do that, okay, 3 minus negative 3, we can do plus positive, right? Leave change, or same change, becomes 6. And then 0 minus negative 4, again, same change, becomes 4. And then, Melissa, did you do anything more with this slope here?
Yeah, and then I don't know what it's called, divide or whatever by 2, and I got 3 over 2.
It's just called simplifying a fraction is what you could call it there, okay? And that's good, okay? Very important that Melissa saw that she could simplify that fraction. And if you saw that you could simplify the fraction there, you need to. Because otherwise, you're trying to compare these two numbers. And when you look at them, you might say to yourself, oh, well, these aren't even the same numbers. There's no way they're perpendicular. But once you simplify that 6/4 to 3/2, now you can see that, well, are these two slopes perpendicular? Yeah. They are, okay? If you look at if you look at these two, you might not at first think they're perpendicular, but you simplify that slope, and now you can see that they are, in fact, perpendicular, okay? And that's why I gave this one to you, because it didn't give you exactly the same numbers at the start. You had to then simplify it, okay? So yes, AB is perpendicular to CD. Question?
So when you're finding a reciprocal, the number is, if it's negative, has to be positive, and then it's the other way around.
Yeah, basically. So for the reciprocal part, that's just like the flipping. So if it's 2, the number 2 over, this number 3, then it should be 3 over 2. Then that's the opposite part. One of the slopes should have a negative in it. The other slope should be positive. Or it could be like negative over negative, but we know that simplifies to positive as well. Does that make sense?
Yeah.
Okay. Okay, does that answer your question too? Good. Okay, good. Other questions? All right, good questions. All right, so we're going to do, excuse me, 2 more here, 2 more problems. Okay, so this first one here, I'm asking you just this question: is lowercase m perpendicular to lowercase n? Remember that sometimes we can name lines not with 2 points. Sometimes we can name lines using a single lowercase letter. Okay, and the way that I'm going to kind of show that here is I'm going to say, okay, here's line m, and line m has equation y equals 3/4 x plus 2. And then I'll say that line n has equation y equals negative 4/3 x plus negative 3. All right. So again, there's our kind of our setup. So again, I'm asking the same question I did before, okay, but I'm changing up the information I'm giving to you here, right? Changing up that some. All right. All right. So I am not giving you 2 points here. I'm not giving you 2 points. So we're not going to be calculating the slope formula. All right, but what I did give you, I gave you the 2 lines in slope-intercept form. Okay. So Mitchell, what is the slope of this top line right here?
3/4.
3/4. And what's the slope of the bottom line?
Negative 4/3.
Negative 4/3. Okay, very good. These are in slope-intercept form, so we can just read the slope right out of the problem. And so the top slope has a slope of 3/4. The bottom slope is a slope of negative 4/3. All right. So let's see here. So let's go to column S. Will these 2 lines then be perpendicular? If the top one has the slope of 3/4 and the bottom one has the slope of negative 4/3, are those perpendicular slopes? Yeah, they are. They're opposite reciprocals. Very good. So we can say that m, lowercase m, is perpendicular to lowercase n, like that. So yes, they are. Okay, just a different set of information. All right. So the last little thing I'm going to have you do here, we'll do together, and then I'll give you guys a little. We're going to switch gears a little bit. Okay. The last thing I'm going to have you do, though, is just like we did for that last problem on the warm-up, okay, where I asked you to write the equation of a line, all right, perpendicular to y equals negative 2x plus 1, and that goes through the point uh, 4, 0. Okay, so this is just like we did in the warm-up, right? Where I told you guys to write the equation, or asked you to write the equation of a line parallel to a given line, and that goes through a given point. Now we're going to write the equation of a line perpendicular to a given line, and it goes through the given point. All right. And again, in geometry, the main way we write the equation of a line is using slope-intercept form. All right. That's the main way we're going to be using to write the equation of a line. I don't really think there's any other time where we will be writing our answers in another form. Okay. So that means we need to come up with y equals mx plus b. We need a slope and a y-intercept. We need to fill in this number, and we need to fill in that number, where the m and the b are. Okay? All right, so let's see here. So, bless you. Let's go to someone here that I haven't called on. Oh, my goodness. We have a lot of people that have it. Okay, so Piper, what is the slope of the line that we are given? -2. Or as a fraction, what would that be?
-2/1.
Yeah, good. Exactly right. Okay? We need to really think about this not as being the number -2, but really as the number -2/1. Okay? And so then, Piper, if the slope of the line we're given is -2/1, and we want our slope to be perpendicular to that, what will our slope have to be? Positive 1/2. You got it. Very good. Okay? So again, folks, let me highlight this. 2/1, okay, that becomes 1/2 for the perpendicular. Okay? It's easy to do, but you got to do it right? Okay, there's more steps to it. Parallel slopes, we just keep the same slope. So if we were trying to do parallel lines, our slope would also be -2/1. But because we're doing a perpendicular slope, you got to flip it and make it the opposite. So it was -2/1, we're going to make it positive 1/2. Okay? And so we get y equals 1/2 x plus b. All right? And then BJ, do you remember what do we do at this point? I got to find what my y-intercept is. It's very similar to what we just did in the warm-up. What did I have you do in the warm-up? You remember? What should I do now? I have this point 4, 0. Where should it go? Okay, so what number? Which one of those numbers do I put in for the x? The 4, and what goes in for the y? 0. You got it. Good job. Exactly right. Very good. All right, so plug those numbers in. 1/2 times 4 is 2. Subtract 2 from both sides, and you get -2 equals b. And so, is this our answer then? -2 equals b, we're done? No, because what were we asked to do? Write the equation of a line. So we need to finish by writing 1/2 x plus -2, or you can put -2, it doesn't really matter. But there it is. Okay, that's the equation of our line. All right, there's the equation of our line. So this line will be perpendicular to this one. And I'll show it to you here too. If you guys have graphing calculators, you can actually see that they're perpendicular to one another. Okay, if I turn on my graphing calculator, you go to the y equals button here, you can type in -2x plus 1, the first line, and you can type in the equation of the second line. I'm going to put parentheses around my fraction, plus -2. Okay, and then I go and graph that. There's the first one, there's the second one. Okay, and don't they look like they make a right angle there? Let me see, I'll get a piece of paper, I'll put my little corner in there, and sure enough, it's a right angle. Okay, so they are perpendicular. Alright, questions on any of that? Alright. So, we're going to stop right there. Okay, and I have a little bit of an activity for you. So, we're going to have some problems like this tonight for homework, so don't, like throw those away or anything like that. Okay, would you like to? Alright. You might? Well, we'll see. I hope you have enough. We'll see. So give it a shot. Alright. Hopefully we'll have it.
By cool, by freeze and steel?
In
Yep.
pairs
Let's give one per person, and then we'll see if we have to share. Because actually, we're having a bunch of students tonight, so it might actually work out. Thank you, Corey. And then I'm also going to pass out another paper.
You got one.
Alright, I may have left my papers in the copy room, so I might have to run back and get those real quick. Alright, I'll be right back. I think I left my papers in the copy room. Okay. So, did everyone get one? Awesome. That before. What I've got for you guys, I'm going to pass out here, okay, is that I've got some properties, okay, that we need to be familiar with, or that you might be familiar with already from like algebra, and then I have their definitions over here, but they're jumbled, okay? So, what I'm going to have you guys do is like cut out each individual property, cut out each individual definition, and then match them, okay, and then match them. All right, and then they'll tape them all on a sheet of paper or something like that, so you guys can have that to refer to. Okay, questions?
Are we doing this with time?
You may like work with the people around you. That's fine. Yeah, if you want some help, because yeah, it might be helpful because. But again, I feel like don't feel like you have to go in order, right? Like try and like logic it out, and stuff like that. I think some of you guys can figure these out without even having to like go through this. They are not in order. You have to jumble them up. They're jumbled up. And I think I have one of your other pencils. So I can do that too. All right, so take one and pass it down. So again, we're exercising our inner child right now.
You crumbled my
Let me see that. I'll show you later. I'll show you biology.
Okay.
Well, first we colored it back.
That's right. Don't forget the first day we colored. Yeah.
Now we're cutting off.
Ooh. I fold this thing. I didn't do 504. I just have the IPs. I haven't gone through those yet, but yeah. Okay.
But those are the two that I've noticed have.
Yeah.
Have little,
Yeah. Okay. Thank you. Okay. They can, yes, yes, that's great. Thank you for the organization. I appreciate that. Yeah. Okay, so you should have something that looks like this, and then again you want to rearrange them so that they match up, obviously. Okay. And when you see stuff like you see the word reflexive, well, what does that sound like? The word reflection, right? Does it help? Okay. I'll kind of come around and get the scrap.
Oh, no, good.
I'm not used to
Thank you. Tear them up. I'm not doing the best I can. Okay.
He said we're gonna.
I'm gonna go grab this one and we're gonna tape it on.
Alright, Alex. I want to go to work.
Where do you work?
He works on the sales process.
No, have you seen that one video? Well, you got a hair extension that's actually built like a hair extension. And when I was in the sheet, and it has a hair extension in his hand. And he kind of just cut his hair. And you know, they're like, shit, can you put his freaking out because he thought he was so bad.
White like skin color. Yeah, probably better.
Okay.
That was what you said.
One of those, pass it down.
Again, try and rearrange those, match those properties, okay? Once you cut them out, once you rearrange them, match your properties. Why am I doing this to you? Because I like to torture my students.
So once you know that one, you can kind of figure out like the addition, multiplication, maybe property quality too.
I'd be like this.
Organization there, so you definitely probably put that everything away.
Unfortunately, that, I thought we might have had,
I got some shade slowly so then they can like.
Alright, so don't take this yet though, right? We have to,
don't take just yet, because we've got to, make sure they're in the right order and stuff like that too.
We're going over this, right?
Oh, absolutely.
I can't see one multiplication property.
Say again?
He wants to reverse.
Oh, they're not in order yet. We're gonna put them in order here. We're gonna put them in order here. Right. Yeah, well. I was gonna say, yeah. Oh, you're looking it up, okay.
You don't know it, look it up.
All right, Bob. Is anyone still cutting out the sheets of paper? Well, match. He's trying to match them up. Match the properties, I think. Okay.
Going up for a flash?
Yeah.
You know what, it's too much.
And then pass it forward.
Talk about him put you in now.
Yeah, his mom just.
No, you just pull your piece of tape off, and then you cut it as you need it. Very simple.
Alright, come on.
I'll have you guys share headphones.
I know. You're welcome.
So remember, guys, don't tape until we, actually check to make sure that you got it in the right order and stuff like that.
It's out? Alright, hold on. You need more tape? It does come apart.
No, mine are not matched up yet. We're going to match them up here in just a few minutes. I want to make sure everyone's done cutting them out first, because it'll be a hot mess otherwise. All right.
Switch you up? What's wrong with this one? Where's your tape?
Okay. We ready? So let's get going here, all right? Let's do this. So remember, we want to put these things, ooh, I just made a mess, in order. Okay, I'm going to do it in a specific order here, just because that's the way I have it on my own paper. And I feel like some of these things do kind of go together. So let me get to my answers. Here we go. All right, the first property we're going to look at. Okay, let's start with the reflexive. Okay, let's start with the reflexive property here. Okay. So anyone have an idea about, whoops, let me zoom out some. Reflexive property. Which one of these things kind of represents the reflexive property? Ideas? Eli, let's go. Okay, if A equals B, then B equals A. I see what you're saying there. It's like a reflection. That acts as a different property, but they are very similar. I can see what you're saying. So it's actually not that property, but good thinking. I like that thing. Antoinette? Yes, it is literally A equals A. That is the reflexive property. Any number is equal to itself. And you might think to yourself, Mr. Widmeyer, that is ridiculous. The reflexive property, that's something we actually have to say. Well, yes, because this is not true for every kind of operation, okay? So the reflexive property is true for for like equals, okay, for equals, but it's not necessarily true for other relationships, okay? So, but in this case, for equality, for an equal sign, for an equation, reflexive property works. Okay, good. That's reflexive property. Okay, so I kind of already gave you the symmetric property, and that's what Eli was talking about there. The symmetric property is A times B equals B times A, or A plus B equals B plus A. Okay? Notice for the symmetric property, we only see the symmetric property for two operations here. You only see multiplication and addition. Is there the symmetric property for subtraction? That is A minus B equal to B minus A? Does A minus B equal B minus A? For example, let me give you numbers, right? Let me give you some actual numbers. Is 3 minus 2 the same thing as 2 minus 3? Which is it? I hear yeses and nos.
No.
It is not, right? 3 minus 2 is 1. 2 minus 3 is negative 1. So, symmetric property only works for multiplication and addition. Same thing with division, right?
Can you blow it up a little bit bigger?
Yes, sorry, I'll blow it up some. Click to the right thing here. There we go. Is that better?
You say this was it?
It's this one. A times B equals B times A. A plus B equals B plus A. Okay? All right, let's do this next one here. The next one we'll do is the transitive property. Transitive property. Ideas here about what that one is? If A equals B, then B equals A? We just, oh, hang here. Yes, if A equals B, then B equals A. Exactly right. If A equals B, then B equals A. Oh, wait, that's, hold on a second. Hold on. I am, oh, okay, hang on. My symmetric property I had backwards. sorry. This is a symmetric property. I apologize. A equals B, then B equals A. That's the other, yeah, okay. That's the symmetric property. I apologize. My paper here was out of order. Okay. Sorry, symmetric property. If A equals B, then B equals A. So that just means you can, like, flip it. Okay, sorry about that. That is the symmetric property, folks. So don't forget, I messed up the order there. Symmetric property is if A equals B, then B equals A. Okay, sorry about that. All right. Transitive property is this one. If A equals B and B equals C, then A equals C. Okay, that's the transitive property. If A equals B and B equals C, then A equals C. Okay. So the transitive property is basically, it's kind of like, again, you see that word trans there, it's like kind of going across. So the idea is that A is equal to B, but B is also equal to C, so therefore A and C must be the same thing, right? That B kind of joins together A and C. If A equals B, but B also equals C, that means A must equal C as well. That's that transitive property. Okay. Anyone think they have the substitution property? Yeah, there you go. Exactly right. If A equals B, then A can be substituted for B in any equation. Okay, it's kind of like, that's nice there. It kind of gives it away, the words and the definition. You will not need to have these things, definitions necessarily memorized. Like, I'm not going to give you, well, you'll need to know a few of these, I guess, actually, yes. You will need to know some of these properties. These first three, well, I'll talk about the ones you'll need to know for sure. Okay.
You're welcome. Tristan, you have paper, you need more? You're welcome.
Okay. All right, the next one we're going to do is the addition property of equality. Addition property of equality. Okay. So which one do we think is the addition property of equality there with the ones we have left over? Addition property. What are we thinking? What's the addition property of equality? Eli, you have an idea?
If A equals B, then A plus B equals B plus C.
You got it. If A equals B, then A plus C equals B plus C. Okay? Addition property of equality. That's that rule that we have for equations where you can add the same thing to both sides and the equation is still true, right? If I have, an equation, I can add 2 to both sides of that equation. Now, I might not always want to add 2 to both sides. I might want to add 7 or 6, or I might not want to add anything in the first place, but you are allowed to add the same thing to both sides of an equation, and it'll still be equal. Okay, good. All right, so likewise to the addition property of equality, we also have the subtraction property of equality. So it's a similar kind of idea. What would be the which one's going to be the subtraction property here? Let's go to Antoinette. What do you say? Exactly right. If A equals B, then A minus C equals B minus C. So that's the subtract the same thing from both sides kind of property that we have. Okay, good. All right, we also have the multiplication property of equality. Okay, multiplication property. We'll do that one next. So, which one is showing that multiplication property of equality then? So that is showing multiplication, but that's a different property actually we're going to talk about. Okay, that's one of the later ones. But there is another one up here that shows multiplication, and that's this one. If A equals B, then A times C equals B times C. I got to scoot my paper up here. All right, and the last of those kind of equation properties is the division property of equality. Right? Which one's the division property of equality here? Which one's the division property? Well, all of these start out if A equals B, if A equals B, if A equals B. So there's one other if A equals B, and it's right here. It says if A equals B and C is not equal to 0, then A divided by C is equal to B divided by C. Why do they have that extra step there of C not equal to 0? Why do we have that extra step in there? All these other ones were just if A equals B, then, if A equals B, then, if A equals B, then. This one says if A equals B and C does not equal 0, then. Why do they have that extra stipulation, or that extra restriction there that C cannot equal 0? Why can't C equal 0 here if we're going to do this? Why can't C equal 0? Anything divided by 0 is not 0. It's not 1 either. When we divide by 0, it's called undefined, right? If you go to your calculator and you try and do 5 divided by 0, I hit enter. You see it gives me an error because we cannot divide by 0, okay? You can't divide by 0. So that's why we have to specify that C is not equal to 0. Okay? A few more properties here. So that took care of all of our algebra kind of properties. And then we have the commutative property. Now here's where it gets a little funky, okay? So the commutative property was that one that I made a mistake on earlier. It's the A times B equals B times A. And the A plus B equals B plus A. That's the commutative property. All right, let's do this distributive property next. Which one of our remaining two is the distributive property? Eli?
For any number A, B, and C, A equals B, B plus C equals A, B plus A.
There it is, right there. Good job, Eli. Exactly right. Okay, there's our properties. And then that leaves the associative property. And so there they all are. Okay, there's the rest. And now I'm going to give me some piece of paper. Everyone doing okay on tape? You need some more? All right. How much more do you need? Just on a strip or? I'm going to try and do this all at once. Here we go. Yeah! It's not bad. Questions? You're going to need some more? Okay, hang on. Yes. Let me get this tape down here. I'll zoom out for you. Okay. That's as far as I can zoom out, but there's the top if you need the top still. Have some more tape. Okay, let me get my stuff taped down here real quick. I'll be right there with you.
Wid. Mr. Wid.
There you go.
Did I get? Where's your scissors?
Oh, where we put them back? There's a box right up front there.
Wait, who's this? It should be
So we're gonna hold on to it right now. I want to add a few more things. If you want to title this paper, okay, we're going to title this Geometric Properties. Okay, Geometric Properties at the top. We're going to go over this some more tomorrow, okay? So we'll go over these more tomorrow. Tonight, like I said, your homework's just going to be some perpendicular line stuff, okay? We'll finish going over these tomorrow.